Cool. Thank you. Thank you, everyone, for joining us. This, I feel, of course, I'm biased, is one of the more exciting sessions of the day. We have a star panel with us today. We have Sara from Google Brain, Pradeep from Amazon Alexa. We have Amirata from Stanford and Victor from JPMorgan. And we're going to deep dive into the past, present, and future of explainable AI, which is a very appropriate topic given our current times. But first, let's start with quick introductions of everybody on the panel. So I'll start with you, Sara. Do you want to give a quick introduction to the audience?
Hi, Amit. So it's lovely to be here. Thank you for the invitation. I'm very much looking forward to this panel as it kind of sits squarely on my main research topic of interest. I'm a researcher at Google Brain, and what I'm really interested in is how do we train models to fulfill multiple criteria, going beyond tested accuracy and training models to be interpretable, compact, fair, and robust. And interpretability really fuels the other three because it allows you to ascertain whether your model is being compromised in some of these other respects.
Sounds good. Thank you, Sara. Do you want to go next, Victor?
Sure. Hello, everyone. I'm also very excited to be here. So I'm a machine learning engineer at JPMorgan within a team which is called AI Acceleration Core Services. And it's broadly our mission is to apply cutting edge ML and AI techniques to improve business processes at JPMorgan. So recently I've been involved in a couple of efforts, mainly in synthetic data generation, where you also have explainability. And XAI is definitely one of the biggest and critical challenges we want to address.
Sounds good. Thanks, Victor. Do you want to go next, Pradeep?
Everyone, I'm a principal scientist at Amazon Alexa. My primary academic background is in computer vision. I've been doing this for nearly 20 years now, except for a detour into Wall Street and trading algorithm development for about 4 years at Citadel Investment Group. So from my point of view, obviously finance, there is a lot of reason to do explainable AI, especially if you're actually doing trading algorithms because you want to know why your system is making money or losing. And there is actually a fair amount of history in that area. Currently, I'm also interested in understanding error patterns in Alexa systems and identifying the root causes of those failures and how they can be improved. It's a multi-stage machine learning system, and where the failures occur is a key area of interest for me.
That's exciting. We're going to get into more details later on in this discussion. And finally, do you want to give a quick intro as well, Amirata?
Hi, everyone. So happy to be here. I'm a PhD student at Stanford, a fifth-year PhD student. I've been mostly focused on applications of machine learning in healthcare. And as a consequence of that, I've been doing a lot of research in interpretability. So making sure interpretable methods are robust, they're concept-based so humans can understand them. And I recently started working on shifting from feature-based interpretability towards data-based interpretability.
Exciting. Cool. Let's kick this off. So the first question I had to the group is, of course, explainable AI is growing rapidly. Where are you seeing the need and the adoption of explainable AI today with examples? And we can kick it off with you, Sara.
So this is an excellent question. It's fun because I've already heard the kind of scattered hints in the panelists' introductions about what I think is the most interesting, or at least what a lot of my research is focused on right now, which is equipping practitioners to audit models in a useful way before they deploy. So in terms of interpretability, I think a lot of the field growing more mature is understanding that different use cases need different tools. So a lot of earlier research, particularly for deep neural networks, was focused on single explanations. You're trying to explain a single prediction. And that has its use case, because there's always going to be, end users who want to know for their particular instance, why did the model make this prediction? But for someone who's deploying a model, understanding the data distribution, and this came across in a few ways in the introductions, talking about outliers, but understanding how do we automatically surface what's most relevant for a particular practitioner to look at, and can they control what part of the distribution they sample to gain an understanding of the model decision boundary. So equipping practitioners with scalable tools that allow them to navigate the model's learned distribution is really exciting, because relating this to real world use cases, the most difficult thing right now is, where do we spend human time? So we know we want to audit models, but how do we equip humans to spend their time wisely and focus on high priority annotations? And this is becoming an ever more urgent challenge because of the scale of our data sets, which are ballooning in size. So how to do that cheaply is also an important task.
Yeah, that's exciting. We're seeing a whole lot of explosion of tools with an open source domain. And the key challenge is how to use those tools in the right way, so you don't go down this rat hole of actually pulling a thread and just going into detail into an area that you don't really know how to recover from or learn key insights from. So I'll pose the question to you, Victor, next. Where are you seeing the need and the adoption of XAI today?
Sure. Let me maybe share 2 or 3 concrete examples. So first one would be how do you use explainable AI to ensure that regulation is met when you do synthetic data generation, for example. So it's exactly what I am doing right now, actually, my current work. So in finance, an increasing interest is being put on synthetic data generation. For example, because we want to share this data with external party, let's say academia. We are collaborating and partnering with a lot of academic researchers. Or you just want to better understand a phenomenon. And for example, in finance, we often want to calibrate things. So let's say you want to calibrate a multi-agent simulator that would generate a realistic mid-price return time series to better understand market impact or better understand agents' intent or behavior. Then the question is, how do you make sure that the data which is generated in an interpretable way, such that you can ensure, you can make sure that regulation is met. And maybe a second example is, I think we need explainable AI to produce more high quality counterfactuals. So, you have this new offline reinforcement learning setting to produce a counterfactual, and people who are developing these tools, this machinery, ask the question, can you find a better policy based on offline data? And in many contexts, data is censored because what one can't see if there is an alternative reality to the current treatment. And they often use this assumption of strong ignorability, meaning you don't have any non-observed confounders. And I think it illustrates, not only it illustrates the fact that causal inference will be, I think, at some point a good framework for one of the good framework for explainability, but also it illustrates the fact that XAI requires a deep understanding of the environment, and we will need high quality counterfactuals like that.
Yeah, it's kind of interesting. From just those 2 answers, you can draw a trend that it's not just explaining the model, but the model is really a sum total of the relationships in the data. So it's also explainability also applies to data. And today with data in some of these industries not really being available, data is created, and so the created data also needs to have a lens of explainability. That's a great thoughts there. Do you want to go next, Amirata?
Sure thing. So I'm going to talk about healthcare and specifically healthcare research. So among all the fields that you're seeing the application of machine learning, healthcare is probably the one that you see the intersection with interpretability the most, because first of all, it's a field with its own people that have been there for as long as humanity has been there. Secondly, just the matters at stake are so important that you cannot risk anything. And the changing trend of healthcare papers has been interpretability has moved as some sort of a gift or an extra thing to the pipeline itself. So a few years ago, when you saw a machine learning paper in health, you would just at most see like people reporting test accuracies. So that was the only part of the pipeline. Then you saw that people would compare their model with doctors. So yeah, our model is like expert level, dermatologist level. Recently, what has happened is that interpretability has become another metric that you have to satisfy for your paper to either get in or to be accepted. And people approach it with different tools. So sometimes you just see people putting a heat map there and trying to like convince the reviewers and the readers, like we did some interpretability, the model is making sense. But as we are going forward, the test is becoming more and more rigorous. So now you have people running human subject experiments. You bring an actual expert in the field to your model and just want to interact with that. And there has been failure cases that has made people more and more enthusiastic about making sure the model is making sense. One example is Stanford chest X-ray data set, where like a very good state-of-the-art paper was published, and then later on there were just more and more doctors coming and talking about the mistakes in that and how the model is going to overfitting on confounders and everything. So I think one recent change and the trend that will go on is that in addition to test accuracy, in addition to comparing with humans, people will incorporate interpretability more and more as just one metric of judging your trained model or your trained algorithm.
Yeah. Yeah, it's a fascinating insight that beyond just kind of regulatory use cases, people like teams are using AI in use cases like healthcare and autonomous car that can be life-threatening if you don't really understand what you're deploying and how it's working. That's fascinating. And gonna finally would love to get your thoughts on this, Pradeep.
Yeah, in my mind, there are three areas of XAI that I am particularly interested in around monitoring deployed models and improving them. So one is detection of errors. The second is understanding of the errors, and the third is correction of errors. So much of the literature is actually in the second part of understanding the behavior of the model. But I see it as a full end-to-end, really the equivalent of software testing for machine learning is how I view XAI as. How do you detect errors? How do you understand why those errors happened, and how do you correct them? And the complexity grows when you look at a production system, and it's not just a single model that you're trying to explain. Most production systems are sequences of multiple machine learning systems. So which system caused the error, and how did those errors accumulate as you go down the chain? Understanding and analyzing them are all important applications.
Yeah, it's a great analogy to the typical software development lifecycle and CI/CD pipeline, and how is that applicable to models? Because models are a piece of software. They're unique in that they can decay and they're trained, but that still kind of throws a lens of like things that we already know and kind of relate to from this world of software to this world of machine learning. And QA is like one of the lenses that you can view explainability from. Well, great. I next, wanted to move on to just talking about like current and recent kind of snafus. We've all heard of recent high-profile snafus that black box AI is causing. There's one in the news every week, so I don't want to kind of mention any of them. How do you see the need for XAI changing in this environment? And I'll start with you, I think this time, Victor.
Yeah, sure. I think it's really like a great question. And I think like obviously for model risk management, we need more explainable AI. So we are also very interested in like looking at regime shift and data distribution drift. For example, when you have such events like COVID crisis. And so regime shifts are large changes in structural relationship of dynamics of a system. And you want to use explainable AI to help for the recalibration of AI models and to ensure robustness. So I know, for example, like an institution like FINRA, Financial Industry Regulatory Authority, so the main regulator for us, they are really looking very carefully at model drift. You know, they deal with something like 428 billion market event per day. So it's like more than Facebook and Twitter combined. So it's really something very important. Another point, like beyond feature importance, you know, feature attribution methods, explainable AI, and especially again, I think causal inference framework can help on the problem of transportability. So we very well know the problem of transfer learning, but transportability is like something slightly different. You want to you know, like how to transfer causal effects, learn at some places to another places, you know. You learn on some population and you apply on new population. And so this question, transportability, is a causal notion, you know, it's not statistical. So I think like XAI change will also benefit from causal inference, maybe to address this type of questions.
Yeah, it's a great point that one of the topics of conversation this year, of course, has been the pandemic, but that has resulted in like shifts in consumer behavior, like in some cases, really dramatic shifts in consumer behavior. And like explainability is like a lens to see what are these changes happening, what are these data changes, what are these drifts, what are these concept drifts or data drifts happening, and why they're happening. And so that can help you better build the next version of the model or choose the next selection of data that might be more robust. So I think I'll pose this question next to Pradeep. How do you see the need for XAI changing given the high-profile snafus and the current context of the pandemic?
Yeah, I think not specifically to the pandemic itself, but one of the things that is missing in XAI or explaining models in natural language processing or computer vision and those sorts of things, compared to what I've seen in finance, is the lack of well-defined factors on which you want to benchmark your model's performance on. So just to give you some context, you know, if you are putting out alpha to trade in a live system, you know, there are well understood factors like the Bara factors, and you know, there's a whole operation that is out there to identify risk factors and then project your new algorithm to those risk factors to see if your new algorithm is actually just latching onto well-known risk factors. And then how do you mitigate so that your alpha is actually truly new and distinguished from what else is out there. In the context of natural language processing or computer vision, we don't have well-defined factors on which we should systematically evaluate each algorithm on. You know, is it just latching on to a few n-gram patterns and saying that this piece of text belongs to one class or the other? Or is it latching on to some specific color pattern in the image to classify it as an aeroplane versus something else rather than something more shape-based or those sorts of things. So people have done those analyses, but we haven't yet systematically defined what are the factors to which you should be benchmarking your algorithms against. And there is also not established ecosystem to discover and add new factors on an ongoing basis, like the way quantitative finance is today, for example, or insurance. Actually, medical insurance is also. So my wife works in the area, and again, there are dedicated teams discovering these factors and adding it on a regular basis so that you can benchmark your models against. That's not yet there in other parts of AI, and so I think that's an important area to look into.
Yeah, it's a good thought that like when you apply the techniques of explainability and explainable AI, what are the guidelines that you should be using? What are the benchmarks? Because we as humans, we use comparison as a way to see is this worse or is this actually better? But yeah, it's a great point that we need those guidelines, those kind of benchmarks, and not just explainability as like a tool, but what is the process? Do you have thoughts to thoughts to share, Sara?
Yeah, it's a broad topic. So I guess there's a few questions being unpacked, which is how do we measure the quality of our interpretability tools? So I've done research in this area, which was mainly relying on how do we measure whether the explanations we give, single explanation methods, are reliable. And in fact, there, I think it's important we develop tests to make sure that an interpretation is both meaningful to an end user and to reliable. There's another theme coming through, which is how do we balance this with what Amirata was talking about earlier with the importance of the domain expert? So we can codify practices, and it's fascinating listening to Victor, because I actually think people who work in finance are particularly innovative because of the constraints they're under from a regulatory perspective. And you can hear it in all the directions he's talking about. But how do we balance codifying certain requirements with empowering something that is generalizable enough to fulfill end users that may have different domains? Like the domain user in a healthcare system is very different from the domain user in a finance environment. And what I would say is, I think most promising are tools which allow the domain user to control how they explore the data set. And I think that's very fascinating from my own research perspective. How can we empower the domain user to navigate based upon their knowledge what is most relevant for them to make a decision about how the model is performing? And it's interesting because I believe this round of questioning started by mentioning perhaps the snafus. And I think snafus are actually an important part of it suggests feedback loops are starting to happen more frequently, where people are able to see algorithm behavior, map it against their own experience, and articulate, this isn't what I expected, this doesn't seem reasonable. And a good interpretability tool should make snafus less likely down the line when it's too late to correct. It should allow people along the way to have the same degree of intuition to be able to audit. And that, I believe, has to be centered on showing subsets of the data that are most relevant for that user. So that's what I'm most interested in right now.
Absolutely. And do you want to chime in, Amirata, as well?
Sure. So thinking about, I think the need has always been the same. You just want to know what your model is doing and be able to fix it. But I think going back to like the very first interpretability papers, when people took gradients and saw the heat map make sense, everyone went nuts. Right now, it's not the same anymore. So yeah, the expectations are much higher. One recent trend that I think will continue more and more is the concept-based interpretability. So it's not enough anymore to just say, these are the important pixels. You want to know, is it because there's a wheel in the image? Is it because of the sky? Or if it's a speech processing system, is it what someone said or the way they said it? Mm-hmm. So this is a very difficult problem by itself. And we needed this for like perfect interpretability. It should be in the language humans can understand. I think another need that is changing, another need that is appearing is that people want to be more involved. So when we talk with doctors, before we would show them the heat map and they would say, okay, that makes sense. But right now, they want to kind of interact with the system and be able to ask for the interpretability. So one recent good example is Beam Kim's TCAP work, where you actually give the user the capability to take care of the interpretability themselves and kind of debug the model and find the model's mistakes. So I think these two aspects, so providing explanations that make more sense and are more human understandable. And secondly, kind of moving away from this rigid notion that we have to have one definition of explainability, that everyone should follow that, and giving people who are going to actually use the system more power to interact with it and interpret it. I think these are the needs that are happening right now.
Yeah, we see that constantly, and we've kind of seen that in the past couple of years as we started off building some of the smaller pieces, and then when we would show the smaller pieces, the ask would be for like the larger pieces, like, okay, you've explained a model prediction, now explain a range of predictions. Okay, you've explained a range of predictions, now give me another lens to a range of predictions, or tell me a range of predictions that I should be looking at. Oh, so now that you have that, tell me how the model is behaving globally. So there's an evolving need as the domain evolves, and as the end user, the actual consumer, is starting to kind of consume all the insights, they want more. And like my take is that it's going to lead us to a set of rich tooling that might be domain specific, that will lead to this future with like a rich ecosystem. And with that, I wanted to hop on to the next question. What are some of the challenges of using XAI today? And I'll start with you, Amirata, again.
Sure. So I think the main challenge is not knowing what to do with it. So we have, I think it's one of the largest growing literature and one of the lowest hanging fruits to just introduce any interpretability methods. There are lots of them. But like talking about software too, interpretability should have been its debugging tool. So for software 1, we have debugging defined. You have methods of doing it. But for software 2, interpretability should have gone that way. But right now, a very famous example, the gender shades project. So you have these gender detection models that are unfair to darker skinned females. And people have done interpretability work on it. And okay, you can say, this is the reason that my model is making this prediction, but what's next? How can I actually debug this model given this information? And I think kind of following other panelists' discussion, one challenge right now is that we are kind of bound to feature-based interpretability or test time interpretability. So I give you a prediction and you want to know what happened. But the main part of interpretability should happen with data, because that's what has trained your model. And there has been works like influence function. We recently worked on a project called Data Shaftly. The question is just much more difficult, because there's not a closed form solution from data to the trained model. It's a very difficult path to go back from. You cannot just take gradients. And I think that's kind of a big challenge right now. So if I want to define the goal of interpretability to finally be able to debug a machine learning model's mistake or its unfairness, etc., what can I do about it?
That's fascinating. Do you want to chime in, Sara?
Yeah, and perhaps I'll just build out a little bit more the second point, because I completely agree. I think interpretability has been typically seen as a post hoc toolkit, which means your model is trained and now let's do acrobatics to explain it. But it's interesting because if you think about it, we're optimizing a model with no constraint for interpretability. And then afterwards, we're shocked. We're like, oh no, it's not interpretable. How could this be? But I absolutely agree. It's a very rich, underserved research direction to think about the training process itself. And in fact, it's interesting because interpretability methods, particularly in deep neural networks, originated from this perspective of we can't get convergence with our models. Let's try and develop tools to figure out what's happening. But we deviated from that. And I think that developing tools, and perhaps what was underline that answer as well is that we've been terrible about translating our ideas to software. In many ways, it's such an underserved area right now. I think that the popularity of some ideas, and frequently when I talk, people will talk about ideas like Lime, which are fantastic ideas, but they've had such widespread use, in particular because the authors thought about the software. They productionized it. They thought about how to build it out. And there needs to be broader thoughtfulness in the same vein. Like, how do we make this efficient? So the last thing I'll say here is that my recent work is focused on how do we leverage signals early on in training to estimate what the model finds challenging. So using the variance or gradients. And this is in many ways attractive because it's a very cheap signal. But once you do that, once you surface something early in training, it opens up a whole host of possible avenues of using interpretability tools to mitigate before you're done training. Absolutely, I think focus on the data pipeline outliers, which Pradeep also mentioned earlier, distribution shift, which has been mentioned a few times, but also can we make this part of the training process? And most critical, which is very related to software and how we operationalize, how can we do this more cheaply? Because papers like influence functions, which was a fantastic paper, is also exorbitant in cost. So we need to do better from an engineering perspective, but also think about proxy measures, which get at that, but which are cheaper.
Yeah, it's a similar problem with using Shapley values. It's really an NP-hard problem. So how do you find something that's usable, right? Not something that's purely theoretical, but complete. That's a great thought. Do you want to chime in, Pradeep?
Yeah, I think there are a few challenges I see, in addition to the computational points and those sorts of things that were brought up. One is something I mentioned already before, which is what are the factors or dimensions along which we should be evaluating models in these different domains, and whose full-time job is it to identify those factors and so sort of propagate it through the rest of the community, whether it is speech understanding or natural language understanding, people speaking in specific accents. Are we systematically underperforming on them? On visual systems, if you look at it, we have chair detectors, couch detectors, dog detectors, all of these things out there, open source. But you take it to a village in India, the chair on which they sit actually looks very, very different from how it looks in a Western world. So our chair detectors don't translate. I've seen a few papers to address that from Facebook and others, but we are not systematically discussing what are the factors that introduce biases in the model. The other part is, can we proactively surface problems in models, like adversarial testing or those sorts of things in a computationally efficient way, so that we are at least generating the data to continuously improve the models. And the final part, I would actually go a little bit beyond what Amirata said, which is not just about debugging, but also providing actionable insights that developers or owners of models can act on. So not just put the onus on the debuggers to identify the problems, but can we actually say this is what is wrong and this is how you fix it? Would speed up the rate at which we are identifying and correcting biases and other issues in the model.
Yes, that makes a lot of sense. Not just be able to be able to get to the end goal of explainability, which is to help you really get deeper insights into how your model is behaving or how your data is behaving. Do you have any final thoughts on this, Victor?
Yes, sure. So I completely agree with all those great answers. Maybe I see like three kinds of challenges. First one is obviously technical, regulatory challenges, and also human challenges. So of course, there is a tons of technical challenges. Maybe we could focus on improving existing methods. So I think like we might need even more model-specific explainability methods. We have a lot of model-agnostic methods which work well, but we can also see like the limitations of those methods. And maybe for some new like state-of-the-art methods, we might need more efficient implementations. And we may need more robustness. I'm especially thinking about like fairness. You know, how do you ensure fairness beyond training data on out of sample data? Very quickly on regulatory challenges, I think like we have like in finance, we have a lot of challenges coming from the regulation. One of them is of course non-discrimination from GDPR, which is also more related maybe to fairness. We all know that simply removing certain variables from a model doesn't ensure predictions that are like, you know, uncorrelated to those protected attributes and those variables. So you really need to make sure that you remove all the protected attribute, but also all the proxies. Right. And you know, under minimal interpretation, like the non-discrimination requirement is kind of ineffective, and under maximal interpretation, it can be like infeasible. So it's like kind of a trade-off. And obviously, to conclude, like you have human challenges. So yes, like explanations that led to understanding and trust are really obviously crucial, and we should maybe more better consider the human side of the equation.
Absolutely, thank you, Victor. Yeah, a lot of challenges, and those are all kind of motivations for us to keep on pushing this kind of domain further. I want to switch tack a little bit and ask each kind of panelist a specific question in their domain. I'll start with you, Sara. I was wondering if you could talk about ongoing and upcoming explainability research advances that you find exciting.
It's interesting. So interpretability research is vast at the moment. Which is exciting because as a field, there's many different perspectives. But I would say there's two particular directions that I'm very excited about. So one is how do we bake in constraints about what we expect to see for interpretability into the model itself? So in many ways, thinking about a computer vision problem, the presumption that we will be able to look at a gradient heat map from a convolutional neural network that's trained only on cross entropy and be able to understand that is infeasible in itself. And so thinking about how we bake in what exactly do we expect to see, what is the perceptual quality of images, but also extending that to language domains. Like when we do sensitivity of attribution, we need to be, we often see like these diffuse heat maps. So that I think is interesting, baking in what we know about how humans can interpret the perceptual ranges in which we understand things to make things more meaningful. The second I would say is how do we rank distributions? So how do we rank the most challenging and the least challenging so that someone can choose what they want to look at? That's been the subject of my most recent work. And so thinking in particular about how to do that early on in training so we can then take steps to mitigate harm throughout training itself.
That sounds exciting. Looking forward to reading those papers, Sara. I wanted to ask you, Pradeep, if you want to talk a little bit about how explainability could be helpful at your work within Alexa. You spoke a little bit about adversarial testing. I just wanted to see if you had more details there.
Yeah, probably I can't go into a lot of details on our roadmap and those sorts of things. But what I would say is a general personal area of interest for me is around going from explanations to actionable insights. You know, that's something I mentioned already. So you have the heat maps or those sorts of visualizations that are very useful, but how do you map it to a quantifiable outcome? You know, it could be a business outcome or simply improve the accuracy of the model, or identifying defects in the model, and on and on. So that I haven't seen enough work on mapping explanations to insights. And again, insights meaning what kind of insights? Is it a human understandable insight, or it is something like you surfacing a new example that is misclassified and you're just throwing it back into the system to the training algorithm to improve it. So classifying the kinds of insights and how do you systematically use these insights to continuously improve the models. I think that's an area of high interest to me. And the other thing I have already mentioned is also identifying factors on which we should be evaluating models. So
that sounds good.
Yeah.
So I want to hop on to you, Amirata. Can you share how explainability is kind of fitting in the changing healthcare domain? You did mention a few points on how the use cases are changing and people's expectations from what they're seeing from explainability are changing. Just wanted to see if you wanted to add some more details there.
Sure. Given the time, I'll be quick about it. So I talked about a few changes that have been happening. I think there is one change or one huge potential for interpretability in healthcare that is not being attended to as much. I'm going to mention 2 examples. Google's Retina paper. They realized that you can train a model to predict gender, age, whether someone smokes or not, many different aspects of a human being just from the retina image, which is something that human doctors cannot do, or just human knowledge is not there.
That's fascinating.
We in our lab worked on a paper where we could predict age, gender, height, weight, given someone's echocardiogram, so video, like sonogram videos of heart, which is again something that is not crystal clear to doctors. And that's exactly where interpretability can do its best. We can literally learn from our models if we can interpret them. But the problem has been very difficult. So Retina model has been out there for more than 2 or 3 years right now. And when I was at Google and after that, stories I've been hearing, no one has actually found out how the model is doing it. So that's kind of an extreme kind of final test of interpretability, which is learning from machine learning, kind of reversing the cycle.
That is a great example. It's scary how powerful machine learning is, and scarier still, we don't know how it works. And finally, Victor, finance and banking are looking closely to use AI to drive the next level of growth. We just had a panel and just kind of prior to this. How do you see explainability helping this goal?
Yes, so I can talk about our effort at JPMorgan. So obviously, explainable AI has been identified by us as one of the technological goals that will make a real difference in the industry. So we recently launched our new Center of Excellence for Explainable AI, and we are partnering with top academic researchers to make sure that we are at the forefront of research and to deliver a best value for the business. So more concretely, XAI, I think in finance can help at multiple technical levels, so multiple domain levels, and to achieve also multiple stakeholders goals. So in terms of technical domain levels, it can be applied to really applied AI where you want to design products in across basically all line of business, investments, retail, private bank. You can also use, and we really need XAI in research, so it's more long-term goals. For example, we have those goals how do you use AI to eradicate financial crime? How do you deal with multi-agent systems? How do you understand the dynamics of the systems? And how do all these things affect financial health? So it's really critical, and obviously explainable AI will help. Last thing on multiple stakeholders goals. So, it's always a kind of a discussion between different kind of people. So you have employees, you have the clients, and you have the regulators. So you want to use AI to empower employees. You want obviously to move up as a company, in the value chain. you also want to use AI to improve the experience of the clients by giving them like insights about how the decision is made. And obviously, like you want to automate like policy understanding and policy compliance for regulation. So it's like in finance, I think explainable AI will be like a holistic approach, 360 degrees, to kind of change the way we monitor the.
Yeah, it's a great broad set of use cases, and that just shows the kind of potential of AI broadly. We are on the clock. Thank you to all the panelists. I loved hearing across research thoughts, consumer application thoughts, banking thoughts, as well as thoughts in healthcare. This was a great conversation. Thank you so much.